Oh, nearly missed it. And we'll make it the link a video, the link available to you. You can share it that way. That's probably the easiest thing. Here we go. Who else have we got? So students all over the place. A few of you on APC, fingers crossed, you're gonna get it. You're gonna be fine. So cool. Snowing in Cambridge. Wow, snow in Cambridge. So I'm just a bit further south. I'm just south of Milton Keynes, and it's not snowing, it's just dark and miserable. So I'm not happy about that. So let's just see if there's anyone else to join in. Give it a couple of minutes. Here we go. Got Lucy joining. And so just some of you may have seen in the message chats at the start while you were in the waiting room. Have you heard the Surveyor Hub podcast? Have you come across it? I did a nice little chat with Malcolm that went out yesterday. I'm still trying to twist Phil Parnham's arm so that I can have a podcast chat with him. I might just do a sneaky recording with him sometime and edit it. Maybe I'll do that. Yes, Claire, come on, Phil, come on. You can do it. If I can do it, you can. So yes, if you've not come across the Surveyor Hub podcast, we're on episode 40. Malcolm was episode 41.
Almost my age.
Yes, yes. Next week actually is a really interesting one that's worth a listen. It's with a guy called John Hambley. It's a surveyor who used to work in central London, and talks about his life experience. Very big into rugby, which I know absolutely nothing about. So that was quite an interesting one, but quite a poignant one. So I do recommend you listening to that one. So we're at 10:34, 35. I'm going to, unless there's anybody joining in, I'm going to have a go at locking the room. So we've got everybody in. There we go. Any late people, I'll just keep an eye on. Right, and so to kick off, for those of you who don't know me, I'm Marion Ellis. I'm managing director of a little company called Blue Box Partners, which some of you may or may not have heard of. And I'm also founder of a thing called the Surveyor Hub, which is a community-free membership group on Facebook and a podcast as well, which we were just talking about. And that's really just all about the life of a surveyor, or what I call the life cycle of a surveyor. And we talk about anything and everything that tends to come up. Tends to have a residential focus, but I'm finding that more and more people from other surveying sectors are getting in touch. So I'm going to start educating myself on all the different flavors of surveyor out there. And I'm also joined today by Phil Parnham, who you may be able to see on your screen. He's one of the founders of Blue Box. Say hello, Phil.
Hello.
Yeah, man, a few words because he doesn't want to be on my podcast. And Phil's a very experienced academic. Some of you will have come across his books, his lectures. Phil would present with Larry Russon the Surveys in Practice roadshows for RICS. So Phil may be well known to many of you. But today the session is with Malcolm Hollis, who I know many of you will know. And if you listen to my interview with him on the podcast, you'll know about his books and that I don't own one of his books anymore because I gave them away. For passing it on to other students to learn from. Malcolm, these sessions came about, we've done one already. In October, we did a session on, actually it came about through an initiative we had a go at called Mentorba, because a lot of students were telling us that they couldn't find any mentors. And let's face it, 2020 has been a bit of a crappy year for many in getting experience of getting out there into properties. And so many of us in the Surveyor Hub have talked about, well, how can we help? And even a little bit does what, you know, we can do what we can. And Malcolm very kindly suggested putting together a couple of webinars. So we did the first one. What was it called, Malcolm?
Case study 1.
Sorry?
Case study 1.
Case study, yeah, case study 1. There you go.
Very sexy,
Very
sexy title.
Very original. And so, you know, I'm not very good with names, hence we've got the Surveyor Hub. You know, does what it says on the tin. But today we've got a more dramatic one called Death by Construction, which, you know, right now with everything that's going on, you know, you've heard of Grenfell, you know, the fire safety, new build quality is pretty poor these days. And, you know, so it's a real focus for us to put into context the work that we do and the impact it has. And we don't want to be scared about that. We've just got to make sure that we're as knowledgeable as we can and we're making the right decisions. And part of that, I mean, my background and experience is in defect and valuation claims for many years. And the thing that I would always pick up on is a surveyor may have the technical ability, but it's having the wisdom to know to make the right decisions in the moment. And it's that trusting your gut instinct and knowing what to do in the moment when you see something or you need to call it out. So with that, I will hand over the controls to Malcolm. You're all on mute because we've got 50 of you in the group, and you know, we're not brilliant at tech here. But Phil and I will manage some of the chat if you've got any questions, and hopefully, depending on timing, we might have a bit of time at the end for a little bit of Q&A. So with that, I'll pass it over to Malcolm. You've got the controls.
Thank you very much, and good morning to all of you. What I want to do is to talk through how things have happened that people have died in construction. At the moment, 40 people a year die in construction on building sites, and some of those, usually single instances, people falling at heights, people inhaling chemicals, all sorts of things of that type. But they're single instant failures. So before I start on that, let's go back to last time, because hold on, we looked at a building, if you remember last time, having worked our way through to it, and it was this one. Now, it's not often that you get the chance of seeing just how bad it is. There's the roof. That's the detail of what it was. And you can see over on the side here that the roof has slipped, tiles are missing, and so on. Okay, this is as it is now, or was a few weeks ago. So what has happened? When they pulled it to pieces, and now you can see the battens going on top of the felt, or the equivalent of, they've had to replace some of the rafters. They've had to strip the roof totally, and then bringing back in those things which are going to be required for a new roof. So you've got a building which over here has got cracks in. They're all being filled. It's now totally re-rendered on that area, and you've got the work that's been done to the roof. Anyway, back to today. There are two sets of things. Last time we started with the inspection, we worked our way through identifying what was the construction, its condition, from which we came out with what was the likely consequence. What was it likely to be that was wrong with the building? Today, we're going the other way around. What's wrong with the building is very obvious. From that, we've got to work back to the liability, the cause, and so on. So this time, we're going the other way around. I set up this matrix last time, and we had a look at it. The failure, usually, you're trying to go down to consequences, maybe going up to see what the cause is. But let's just see what's been happening. This is South Korea, Seoul. It's the biggest of the shopping centres. It's the Harrods of the area. It is incredibly posh shopping, or was. That is what happened. It collapsed, or half of the building collapsed, to be more precise. And within it, it's the Sampoon department store. You got 502 people killed, nearly 1,000 people injured. Now, things like this don't just happen on a whim. There is a reason. And our job is to try and work back to identify that reason. So here we have some of the information that became available. Up in the top left, you can see the building disintegrating. Some of that's coming down on the outside. A lot of it drops straight the way through the inside. Down at the bottom right, you've got the air conditioning units on the roof, which have been moved. Each one of those units is 15 tons. So that's 45 tons of equipment on a roof, vibrating. So let's see. In terms of the building as it was put up, the columns were undersized. That's the size they should have been. What they turned out was that. So in terms of the inside, not only were the columns the undersized, but also they took some of them out to get the escalators in. So you got a building which now we know has been reduced in terms of its strength. It's been reduced in terms of the supports for that strength. 29th June 1995, 25 years ago, the roof gave way, the air conditioning units came through, columns fell, and it took 20 seconds, they reckon, from the beginning to the end. But that is, of course, rubbish. It wasn't 20 seconds. It was 2.5 years into this that you could have stopped anywhere through that, and people's lives would have been saved. In the investigations, design errors were found. We've talked about some of those. There were many construction faults, poor construction quality, reduction in the cross-section, changes made when they added an extra floor, which was to be a roller skating rink, and was then changed to a restaurant. I had forgotten that eating in that part of the world, you tend to sit on the floor. So the floor became a heated floor so that the diners were not left in too much discomfort. And the heated floor is yet more weight. It was completed in 1989. Again, you look at the building, you see the changes, you see the errors, you see the alterations. Now, none of those in themselves would have caused the building to fail. These buildings are built with something like a factor of safety of 2.5 times. So if you're reducing the quality of the construction, the strength, you're probably only reducing the ability of that building to withstand by 50%, 60%. It should still stand up. And of course it did. So what we need to know is why it began to fail. And in that, what the warnings were. We have a change of use too. It was originally going to be put up as an office building, but they changed it to a shop. The consequences of that, as I've already mentioned, is the columns being removed to get the escalators in, the columns which are undersized. We've got changes in the design with the weight of an extra floor. We've got also the heated concrete floor and overloading through that by 4 times. Now that again doesn't mean that we've got the problems. What we do have is a flat roof construction, a flat slab construction. This is where your slab is reinforced concrete and it's supported on columns which we've already talked about. But it is vulnerable if you start getting weaknesses and failures to those columns punching through that roof construction. And over on the left, you can see one that didn't completely collapse, but where the top floor has actually dropped through those columns. In this one, adding to the construction problems we already mentioned and the weaknesses which have been created, the steelwork which was put in had undersized reinforcement bars and not as many as there should have been. There should have been 16 and there are only 8, and their size was severely reduced. So we yet again have something which created problems. And also the reinforcement bars were put in the wrong place. Instead of being something like 5 centimeters from the top, because obviously what you want to do is to stop it doing that. That's why they're there. You've got them lower down, which actually means it'd be pretty good to stop it doing that, but that's not the way the forces were going to act. Again, 20% reduction in the ability of that building to stand. Oh, minor thing, they'd use seawater to mix the concrete. So this is a building which had a death knell to it anyway, because that would have deteriorated the reinforcement within it, so that it would have deteriorated over a period of time, but not the time from when it was built to when it collapsed. Something triggered it, something set up the problem. That's the factor of safety you start with, and that wasn't totally eliminated. Construction, we've got the defective and misuse of the slab construction. We've got the design being changed. We've got added loading without adjustment in the design. We've got 50 tons of air conditioning units in use and being moved. When they moved it, each of those units, they pushed them across the top roof of that part of the building. So that you had a rolling weight of 50 tons moved across a roof, which is flat slab construction and wasn't built to take that sort of loading. Here's going to be a commonality. The people who owned the building were told by the company building and doing the work that the design was unsafe. The owners of the building reacted to that. They sacked the builders and appointed their own contractors. Raise a problem. It's amazing how common this is going to be, that you instantly get a pink slip. The investigation was carried out, and it took 2 and a bit years, this, identified the mistakes and the errors that we've talked about. And those are the ones which create the problem. The store opened in 1990. About 40,000 people were visiting each day. They pinpointed eventually the trigger point. It was discovered 2 years before the collapse, that the building's 3 rooftop air conditioning units have been moved. And it's not just the moving it, it's the fact that they're vibrating. And the vibration is what sets up the beginnings of the cracking and its opening. During the day of the collapse, it was fairly obvious something wasn't right. And that was something which meant that the owners of the building, the owners of the shop, began to get people to move expensive items of merchandise out of the building. They began to get things which could be severely damaged and which were expensive removed. Not their staff, not the people within the building. They didn't shut it, they didn't close it down. But what they did do is they turned off the air conditioning. Now, in August in Seoul, it gets what I suppose I would regard as warm. And the temperature inside got to over 40 degrees centigrade, pretty close to 100 degrees, over 100 degrees Fahrenheit. But they left the store open. The cracks began to develop in the roof space. Gradually, the building began to deteriorate until within a 20-second period, it fell. The various people involved were charged with human ignorance, criminal negligence, and greed. They were found guilty. Li Jun, who owned the building, got 10.5 years in prison. His son, who was the chief executive officer, got 7 years. But buildings like this don't get up unless somebody has faked the details. Somebody has accepted something where they should have said, nope, this is not a good enough quality, this is not a good enough design. And one of the city officials, who was the chief administrator for the area, was sentenced to 3 years in jail for bribery. He became sucked into the concealment of what was to be a major series of errors. The former chief in the area was found guilty of accepting a bribe of, well, it's about £10,000. He got 10 years. It's £1,000 a year, that was. So you're left here with the end product of fake information, warnings which have not been taken into account. You've got weak construction. You've got a building which collapsed because of the vibrations that were set up within it. A few days later, here in England, in Ashford, you have, well, let's have a look. I was brought into this the day after the collapse, so that what I am showing you here is some of the most contemporaneous illustrations that there were available. And that's the newspaper photographs of the time. Not terribly clean, not terribly sharp, because it's a newspaper. When I got there, it's just a pile of rubble. It's the remnants of a building and in part the bodies of the people who were within it at the time. Now I found the only way I could stop and think was to do a drawing of what I was seeing. And through that, you begin to register, you begin to note. You see the roof surface at the top hanging down over the edge here. You see the nature of the construction beginning to come to you as you do the drawing. You can see down here how the planks are. But where those planks, which are concrete planks going the width of the building, are located, is not going to be any help. They got 4 bodies out of this, some on the ground floor, some on the first floor, and some are part bodies on the first floor, not the total body. So it's fairly obvious that whoever was there was on the first floor. The majority of them were on the first floor. But to get those bodies out, the fire brigade has had to move a lot of the stuff out of the way. So you're not going to a prime site. You're not going to something where, as you look around, what you're seeing is the information at the time of the failure. You're seeing something which has already been contaminated by, quite obviously, the need to withdraw the bodies and recover them. So you start looking. And things begin to jar. You see that, which is not the way you'd expect a collapse to occur. It's a very clean, straight, vertical edge. You see where you have got in the aerial, in the photographs in the paper, and what you don't have here is a hangover in that location. So I'll just go back to there, and here we can see just about that there is roof. This is the first floor. It's missing here because it's been removed. It's there, but not there. You've got a brick pier with an external face to it, and the external face isn't tied into the inner. So whatever the dimensions of that column are going to be, well, they're not going to be the dimensions which are doing the job. And that is there, the aerial photograph, you can just about see. Going in a bit closer, you can see how the windows have been ripped off. Sitting in a pier here, which is 1.5 bricks wide. Now I'm going to use the old dimensions, that's 13.5 inches. Those should have been 18. In other words, the outer face should have been doing a job. It isn't. So we've got a building which is under strength. We've also got some steelwork sitting in there, which, looking at the construction around it, doesn't leave you very confident. The rainwater downpipe at that location as well. But that doesn't look like neat, tidy brickwork to me. It looks like a cobble. Here's the remains of one of the concrete planks going right the way across, sitting on the steel, as you would expect. So, using one of my sketches here, I had set up a matrix at the time I was first there, labeling the floors in numbers and the columns as letters, so that I could indicate or pinpoint where certain things were. Here, as you can see in greater detail, how the outside of the pier has just peeled off. Detail here, it's a steel beam, I'll get you closer. There's the steel beam just about visible at the bottom. And I also checked whether these were vertical, how much they're out of alignment. They seem pretty good. Up at the top there, you can see that the bubble on that spirit level is pretty well in the middle. So as you're wandering around now, you're collecting information, you're looking, you're trying to record as much as you can, because it's the first opportunity that anybody has had to go into the building and do this sort of work. I didn't go up to the second floor because all of this area, which is the kitchen, toilets, and so on, all of that was too dangerous. The first floor wasn't exactly one I was happy about, but it was in a better condition than the top floor. And then there's this. What do you see? Why is that dirty at that point? Let's go a bit closer. You can see the surface marks there. What's been going on in sufficient time for that to happen? In other words, that's not since the building fell down. There you're looking at something that has been probably days, weeks, months, certainly weeks. And there's obviously a staining. And then you wander around the inside. This is the bottom of one of the piers. And you wonder what that is. And what that is asphalt. So the column is sitting on an asphalt bed at that point. So the asphalt was put in there first, and it was a roof covering, and then the pier has been put down on top of it as far as the base is concerned. And then you look at the material which is there, you're looking at the quality of the bricks, you're looking at how these relationships work down here. the remains of the concrete planks. And oddly enough, you get damp-proof courses where you don't expect them to be. You get down here holes right the way through the piers and ones for the heating system to go there, undermining or reducing the quality. You measure the piers. That one you can see is 13.5 by 13.5, not 18 by 18 as it should have been. And again, the brickwork, you usually expect piers to be neatly tied together with the bricks being laid in a way that you can see they're forming a solid mass. These were just thrown in. More pipes running through. And this time, what have we got? Just about 9 inches by 13.5. And that is where the outside leaf was put on top of it, but not fixed. So going back to one of my doodles, you've got bricks in a higgledy-piggledy way, not forming a uniform whole, and that is the pier on which an example of a pier, correct myself, that is there within the building. The front part not tied in, the untidy brickwork. You have a building that you regard as being weak. But then you're looking at this from it being exposed. You're not looking at this on the basis of what you'd see before anything fell down. So each bay has got brickwork, has got the 3 levels. We've got the concrete beams that go across these planks. We've got infill panels at each level, which are block work, which has been rendered. And there at the far end, you become interested in the way the building has collapsed. Because there the end wall of the building has peeled off and fallen into the car park. The other parts, they've fallen inside, internally. So somewhere, the inside has been brought down, and as it come down, it's pushed the back off. All of those become relevant as we go further on. But all we're doing at this stage is trying desperately to collect information because it won't be there in the long term. Somebody's going to go in there and start tidying up. And at that stage, all of this is going to be missing. So the whole of what I was doing was making sure I had drawings, sketches, notes, measurements, just so that I had a record. From that, I wanted to get some idea of how it was built and, putting it bluntly, what it looked like. And we've got choices. We start off with a static analysis. Let's review the evidence that comes from drawings, reports, witness statements, and aerial photographs. Let's then, from that, recommend the deconstruction of the remains so we can test materials, look at how it is actually constructed. And then we want to try and verify what we believe is our theories. And usually we're using pathology or epidemiology. And now analysing the cause of the building failures and collapses, we're researching into the studies of the cause of such failures. And we've particularly come across this again because these 3 subjects are all interrelated. Now, preliminary inspection identifies what has been disturbed, where the bodies probably were, but we keep an open mind. When it comes to the investigation stage, we're going to try and recreate the appearance and construction of the building prior to the collapse, so we know how much it's been changed. We have got information that will come from aerial photographs, the press images we've already seen, but we're going to look at the drawings that were available at the time of the collapse. We want witness statements, the people who were there at the time. We want to know what they saw, what they were doing, what was happening. The pathology reports, or the pathologist's report, will report on the bodies. so that one can work out where people were there and a lot of other things which we'll come to. And again, trying to establish what the construction was and any issues of stability. I've got a report to clients. I can do an interim report, I can come up with theories, but what we need is more information and evidence. So we're going to analyse that, we're going to look at the remains of the building, and the final stage will be try and verify our conclusions. So we've done a first look, and we've recorded as much as we can. Now it's the examination of the drawings, from which we hope we can answer the questions. What was the building like before the collapse? And here are the drawings. We're talking about the building being this one. They're putting a new building up here, steel framed, with the middle bit here being the entrance hall, which one side would go off into that building, the old one, that into the new. So that you've got a building which has got construction work going up and alongside. Vibration, digging out foundations, disturbing the ground. So let's look at what we've got further. Here is the drawing of the ground floor in a section. And you might notice that one shows it as a single-story construction, and one shows it as more than that. Somebody has altered this. Somebody has changed it. Here's the floor plan. Now down the left-hand side here, these are simply the notes on the drawing because they're pretty difficult to read. So those, forget what's down on the side of the plan and look at what's written there. And what we've got is the dimensions of the blockwork, brickwork, and the cavity in the construction, and the dimensions of the piers that should be there. And we've got floor plans drawn at a different time, totally different hand, different lettering, different clarity. And here we see something which is relevant. A foundation marked out, and here a steel column, a steel pier. So we're looking at somebody having identified that this building is not strong enough as it sits there. It needs strengthening by the addition of additional steel columns. And to fit those in, they're going to have to chase their way through the existing construction so that you can get those columns in, and down at the bottom you need some space so that you can dig out the foundations. Somebody has decided the building is not strong enough as it was and as it existed prior to the building work. Crudely, I've sketched out there what is taking place. Probably, and almost certainly, I've made the holes in the individual panels too big. If we go back to that one where we saw the staining underneath the opening, which is in fact this part, because that's the bit that remained. When the building collapsed, that came away, but that was already there as a cut, which is why we end up with a slightly unusual finish where the blocks are split in such a neat way. When buildings collapse, you don't get that. It comes away as one section, section after section, collapsing in on itself. You don't get a nice, neat vertical line. That had been cut away before the building collapsed, as had some of the others. So we've got that marking that we were looking at before, indicating that this was probably the size of the chase, directly above the middle transom of the window. concrete planks that we've seen before. We're looking at that being where the column was going to go up. So we've got non-reliability in the drawings. One lot's showing something, another lot showing something else. They're showing the building has been altered after part of it was completed. So we now know, if these are right, that we're looking at extra loading being placed upon the building. We're talking about the changes from the final build. And in those changes, there are some of the other things. If we go back to what was supposed to be there, this should be a reinforced concrete ring. A ring going around the building, acting as lintels right the way around and tying it all together nice and neatly. Whereas what we saw when we started looking in more detail originally and begin to work it out, that they have done individual steel lintels, I suppose, as beams across each opening, untied together, so that they're individual, so that there is no continuity. If one of those piers begins to distort or fail, it's going to take with it the lintel, as opposed to what would normally happen. If you've got the ring beam, it could move away and not severely damage the construction that was there, because there'd be that extra support that would come from it. So we've got the examination of the drawings, and we've got some wobbles in our mind as we think about it. Now let's look at Mr. Radcliffe's, or Dr. Radcliffe's, pathologist's report. He looks at more things than you'd expect. Not only is he looking at the bodies and what caused the problems and so on, he also notes things, what they were wearing. No hard hats, no protective clothing or protective footwear. He also looks at the alcohol levels. This collapse took place just after lunch, and the blood alcohol levels obviously are relevant because somebody who's working with heavy equipment and they were cutting away those brick panels, block panels, to get those new steel vertical columns in. Well, if you've had a drink at lunchtime, how accurate is your use of a Kango? I mean, mine would be pretty crap even without the alcohol. Might be better with it. But what you've got is a percussion instrument which is doing a vibration job, and it's cutting into the building, and you need it to be done accurately. Careless use of that could have set up the problems. He also listed the names and occupations of those who died: the site manager, contractor, carpenter, and labourer. So the pathologist report has told us something. It's going to help us know where the bodies were. Now let's look at the witness statements. This is where we're going to try and get some information from those who were there on the site. There are about 23 people working on the site, so there's 19 people who should be able to tell you what happened. And this is what you get. The suggestion that the building was distorted before the collapse took place. Many of the statements referred to the piers on the front elevation being distorted and leaning out. In other cases, leading to most of the witnesses concluding that the building had been built out of plan. Column C2, which is the one I've pointed to, was kinked in and out and was not straight. 5 inches in and out, or 2 or 3 inches one side, 1.5 inches another, irregular in another. Quite a bit of distortion is another piece of evidence. The building is all over the place, 2 to 5, 2.5 to 3 inches out of plumb. Building not plumb. Cracks inside at bottom of piers. Piers C2 undulating towards building. The examination of the remainder of the building, however, did not support all of these statements. There's an important thing about witness statements. They should be taken independently, immediately at the earliest opportunity. These are taken a year later, by which time there is too great a link and commonality. Either they're right, and this is what they actually saw, and they did that independently, or they have actually had a chance to talk about themselves and say, hey, did you notice this? Oh yeah, I suppose it was. And suddenly it's all contaminated evidence. It doesn't work. So if you're going to get witness statements, it's there the next day that you should be banging on their doors to try and collect their recollections of what was taking place. And in fact, now there is actually guidance to that very effect. The information about the work in progress at the time of the collapse is relevant. Panels were being cut on the first floor near the middle. Well, in fact, they were being cut roughly where I've put the arrows in. Based on the information, it was between A2 and B2, which is actually further over this way, or C and D. There's reference to the use of a Kango hammer to remove the blockwork underneath the windows to put the new steel columns in. But it was silent before the building collapsed. Whatever they'd done, whatever they'd started off, did not cause the building to fall down. What it did, well, is expose the most likely causes. Where were the bodies? Taken from the pathologist's report, witness statements, and all of the others, the bodies, well, 3 of them, are where those arrows show. One body was right over here. Nothing to do with what was going on here. But 3 of them were right on top of each other. The site manager's body was found at the bottom of C2D2. One of the others was nearer the center, and they were recovered from the ground floor. Part of one of them was on the first floor. Going back to evaluation of witness statements, we've already decided that they're not really independent. The nature of them suggests that they corroborated. And the guidance noted in taking witness statements records that witness statements should be normally taken as soon as possible to ensure that the events are still fresh in the mind of the witness. And the evidence is recorded before the witness is tempted, has the opportunity to discuss their evidence with others. That's from the guidance that is issued and is common and is applied in all cases. And we're trying to collect stuff we can rely on. So we've got newspaper reports, we've got information that comes from their photographs as the earliest, and then we work our way back. And here's the bit of the roof hanging over that I referred to before. Interestingly enough, the timetable of the tragedy set out in the newspaper there says that the collapse began, well, the collapse took place at 2 o'clock, and it was 2 o'clock in the morning after that they found the last of the bodies. So 12 hours was spent moving planks, moving debris to get to where the bodies were. And our building before, well, this is the back of the building. We've got 3 floors of offices, and here we've got the staircase, utility, toilet area. So we've looked at the detail so far, and let's look at the aerial photographs. This right-hand one, the black and white, was taken about 1960. The one on the left, let's get a bit closer so we can see what we're looking at. the one now on the right, 1990, we can see that something hasn't been maintained very well. We've got ponding on the roof, where rainwater downpipes have probably got blocked. We've got something which has got an additional line of issues, which we've got to think about. And then you come down to what it is that you're going to recommend. We've so far done the first part. We've done an inspection, initial. We've done an inspection of the original construction drawings, aerial photographs, pathologist report, witness statements. And now we come to the biggie. If you look at the prices there, they're all 1995 ones in terms of fees, £75,000 to deconstruct the remains. That's not just fees, it's the builder and the process, because you're going to have to clear everything off the site. You're going to have to log it. As you do, you're going to have to mark where it was. You need reference points to do it. And the value benefit of it is going to be pretty high. And you might want to do an analysis of past building failures of this type, except in this country, this is the rarity. Then we will work on other things, which is modeling and so on, to test the hypothesis. So we come to the deconstruction. We've got the dynamic analysis, we've got verification, and we've got determination of the cause of the collapse, the sequence of the collapse, and the liability. So here we've got the piers being marked off. So what I labelled originally as A, B, C, D, E have now been slightly changed because the matrix that's been used starts at the very rear corner of the part that didn't fall down. All of the areas begin to be marked off, but you can see that all the debris has now been removed. And what now becomes unearthed is something like that. The drain's directly under one of those brick piers. So you're looking at something where over in the corner here, where you've got a blocked rainwater pipe, this, how on earth you can put a pier on top of the drain, I don't know, and I probably never will. And then you look at the deconstruction of the piers. What we've got left, we want to look at and examine. We want to be able to find out what was going on. So we got back to that asphalt where we know this pier has been built on top of the original roof. So where we are looking is over here. That's where we are at this point. And then you start looking into details. Some of the brickwork gets taken off the outside, and you find a damp-proof course flashing there, laid into the brick courses. That's because that used to be the roof. You wouldn't expect that at each level normally. It is something which goes back to confirm that this part is the fill where on top of that the asphalt lay. The concrete beams, as we've seen before, the planks are all in the place you'd expect them to be. So gradually now, we're going to take block by block out to see what is there. That's the detail over in that corner. Brickwork on top of the blockwork there. Here's we've got one of the concrete lintels, and that was another one. Separation between the two, so there's no continuity. And we've got our, hang on, what are we looking at? What is it that's going on here? You've got the pier placed on top of what was the parapet wall and blockwork, and it's balanced. It's balanced with just that support on the outside. It's balanced with just those bricks on the inside. And it's sitting on a lightweight concrete block. So the floors that have been added above for the construction, and the weight of those floors and the weight of the roof is sitting in that particular place where you've got the brick pier directly on top of a block. And now it gets interesting because you've got the HSE there, you've got the National Builders Federation, and they're there because they're representing the people who died, together with various solicitors. To my dying day, I will never understand why they didn't kick it out of the way and do it properly. Why they go to the effort of trying to balance a pier on top of a block. I do not know. It isn't as if these bricks that were propped up were even linked to or tied back onto the surface. They were just filling in a gap rather than adding support. On the other side of the building, this is the back where I've indicated, you've got the same sort of thing going on. Here, that plinth, which was the original, and you see the asphalt behind there, that was where the roof was dressed up. Parapet with the coping on top, that is what that edge was. So my doodles again, my sketches, show you what you're looking at. And it looks a lot better in the drawings there than it actually was when you're standing on the site when you first see this. And you think, how on earth can anyone do that? But you've got 4 people's deaths on your hands. It was constructed as a single-story building in 1969. It's had 2 floors added. It's put up before health and safety issues. The contractors who are carrying out the work to do the alterations were held it being difficult to blame the contractor for carrying out the work for not anticipating what would happen. Let's just look at what they could have found, because all of these things we know about. When you alter an old building, built before the 5th Amendment, you know that it may not be as robust as you would like. Use of heavy plant near the key structural elements is a risk, a concern. These are all of the pieces of legislation which relate to this type of work. And when it comes to the contractors having no liability, well, let's just look. There's a lack of a risk assessment being carried out, a lack of a preliminary structural survey, poor planning of demolition, absence of temporary structures to support. I couldn't believe that there wasn't a single piece of property, a simple piece of scaffold that was in amongst the debris. There's a lack of demolition method statements, lack of supervision, a lack of protective clothing, a failure to identify the existing construction, and the failure to consider the adequacy of the dimensions of those parts of the building. Those are things that working are being done better, and had they been done better, this would not have resulted almost certainly in the deaths of all of these people. After 4 years of investigation, no one has been brought to book for what remains one of the single worst construction accidents to have taken place. And suddenly you compare the two. So, here in Ashford, construction errors, changes to the design, changes to the design adding extra weight, and a verdict which was gross incompetence and total irresponsibility. That's the Health and Safety Executive, get it right in the end, report upon the original builder, not on the ones doing the work. Those who died, taking away life through errors of people's judgment. In amongst the rubbish, there were so many things that you came across, like the hat that I started with, like this coffee cup. No one was held liable. No one was fined. No one went to prison. Now we come to closer to today. The cladding was added to Grenfell Tower in 2015-16. Celotex was the main material used, although Kingspan was also used in some places. And that insulation was placed behind a aluminium sheet and set off the wall, leaving an air gap at the back. They launched Celotex, the product, PIR, rigid board insulation, which is now going to be referred to as RS5000. I'll just turn that off for a moment. And they maintained it was suitable for use on buildings over 18 metres. They stopped the supply of this in June 2015, immediately after the fire. Celotex head office have made very damning comments of their own workforce in relation to this. The workforce maintained that it was only recently determined there was a difference between the product specification that was tested and the product that was being sold. The one they got through the test was a totally different product. You've got different materials on it, you've got different outside face and a different composition. They tested that material in 2017, just after the failure of the building and the sadness of the loss of lives. And they found that in the test that flames quickly damaged the aluminium panels, taking hold and moving from floor to floor. Burning drops of melted plastic fell like rain to create a pool of fire below. They had to abandon the test to put it out because so great was the burning. Celotex sent a sample. We're surprised when we learned in August that while this sample continues to meet the standards for class 1, the sample did not achieve a class A rating. They shouldn't have been surprised. They knew that they'd changed the specification. But let's talk about Kingspan, who didn't provide much insulation for this product, but did produce for this building, but did produce some. They amended the materials. They got ratings for a material that was not the one that was being used. They got a rating for that material and then used that to promote and publish the material that was being used and which was used on this building. The newer product has a quicker time to ignition and double the heat output. Celotex provided intentionally deliberate and dishonest description of the product as being safe for high-rise. They withdrew it from the market in June 2015. Just before the inquiry, 3 directors of Kingspan cashed in £6 million worth of shares. They knew. Kingspan stressed that the bulk of the insulation was not them. They said it failed the test because it was only part of the insulation. It was clad by something else. It was the whole system that should be identified. The analysis in 2008 identified that the product had a quicker time to ignition and double heat out. 2008, that's 9 years. It burnt very ferociously and gave the top cavity barrier a serious hammering. The building regulations permitted the use of this material as part of a cladding system, provided the overall cladding system was compliant. It wasn't. A senior Kingspan employee said, when a builder questioned the fire safety of this product, before the fire, before the problems, whilst they were looking at choosing whether to go up, that they should go and, you can read that. Everyone was blaming everyone else, but the fire tests carried out were not representative. The materials that have been tested which got performance were not the ones being used. It is fraud. It is deliberate misleading. The cladding was the primary cause of the fire. So to conclude, it was avoidable. It should have been avoided. People have been, I think, guilty of manslaughter, criminal deception, fraud, negligence. And they are guilty of that in what is now written. So will they be sent to jail, as we saw in Sampoon? Will they be fined heavily? What is going to happen? But in each of these cases, we're looking at things which should have been avoided, which could have been avoided, and yet people failed to take notice. In terms of Grenfell, in this morning's Times, you can read to the effect that here we have got a warning that was issued by the National Building Federation 4 years before about the product and the risks that were being taken place, saying it should never have happened. Thank you.
There we go, I'm on mute. Thank you for that, Malcolm. Boy, that is sobering stuff, isn't it? Thank you so much for taking the time to put that together. Any questions from anybody? We've had sort of a few comments in the chat, but I think the overall view would be shock, actually, in terms of how people are feeling about it. But any questions or any observations anybody wants to make? Yeah, Claire, shocking. You know, when you get this insight, you understand how these things have started to happen. You think, how could it be? Atul says, should we abandon the phase value engineering approach from construction? Because Grenfell was value engineered. What are thoughts on that, Malcolm or Phil?
Yeah, I think what's coming out from the inquiry into Grenfell is just that dislocation of somebody with that overall responsibility for safety, for the design, and I think, you know, Malcolm's your example of like, who the hell built a brick pier off a balanced blockwork, you know, and it's just years ago, but it applies today so clearly, you know, and I think, yeah, there's going to be lots of questions, but I think what you've raised, Malcolm, is that question mark at the end is, will we learn from it, and will people be called to account? That's my concern. So
I'll just read a few lines from today's Times. Barbara Lane told the National House Building Council in October 2014 of her serious concerns over the use of K15 foam insulation made by Kingspan on tall buildings. The risks had been identified, they'd been notified, and all that they could do, Kingspan, was tell those people to F off. And all those people died as a result.
Mm.
I think just one final thing, and I'll shut up, is what I learned from that Grenfell podcast, especially the 1 through 7 episode, the most recent one, is that all of those implied in this, the British Board of Agreement, the Building Research Establishment and their conduct of the tests, but also LABC, you know, the local authority building control, you know, the people that I've always trusted, that they gave type approval to the Grenfell insulation, it seems. And that type approval was almost written by Kingspan. And it's like what I went away from that thinking, and from all of these case studies, is who can you trust?
Oh, absolutely. Absolutely. And I think, I mean, there's a few comments that are coming up here. David Powell says, you know, concern is that the construction process is still highly disjointed. And you're right, it goes from, you know, different sort of pieces and different people involved, and there's often not one person responsible for the whole thing. I think one of the things that's come out of Grenfell, and obviously it's very tragic, and with the way that social media now is, and the very public inquiry that's going on globally, not just here, is the real focus on the decisions that people are making in the moment, but the pressures and working conditions that people are put under, particularly for trainees and young people in the profession, you know, where they don't feel that they can call it out, they don't feel that they can ask the stupid question. And if that's one thing I think you should all take away from that, is if there's any doubt, if you're not sure, call it out and ask the question, because there's so many points through Grenfell and through others, you know, where things could have been done differently, but we've got to make sure that we do that, you know, but that's hard. It's hard anyway, but particularly I think for somebody who's junior and feels a bit less experienced. But use your network, use your contacts, use the people that you talk to about. Go into the hub and ask, is this right? You know, really go ahead and do that, and that will help you give that better sense of judgment. There was a question here from Matt Ball about valuation. And he says, if a valuer did a valuation for mortgage purposes on Grenfell pre-fire, could they now potentially, be sued? Would there potentially be a claim? That is a really difficult one. I would say it would all come down to the lender's guidance, and was the property suitable for mortgage lending in the first place? It was high rise, you know, local authority or ex-local, it would have been an ex-local authority, so it's highly unlikely that it would have been suitable for mortgage. But the question might be, it will come out with lenders in the future. I think I would have thought it would be highly insensitive for a lender to sue somebody, sue a surveyor, given this is such a public inquiry. But never say never. Having gone through the last recession and seeing how lenders have sued surveyors, we used to call them confetti claims, because they'd come through as part of a postcode, and we might sue you in the future, we think we might have a claim. You know, it was a terrible time. So never say never. I would have thought it'd be highly insensitive, but it would come back to what are the lenders' requirements in the first place on that. So a bit of a tricky one, that matter, unfortunately. Japanese knotweed. Don't we want to go down that rabbit hole, Michael? In terms of how that is being used, but I think it does highlight the lot of conflicts that we have in the industry, that a lot of these organizations, businesses have a vested interest you know, but that's the only way that people can get research and insight, and that then forms the opinion and standard of what should be done. So go that step further, find out, call it out. But yeah, but I think we see that across the whole of our society in many ways, really. Yeah, any other final thoughts before we round out on that? Any other questions? Glasses on, I can see.
Somebody's typing away in the corner there.
Yeah.
Malcolm, can I ask one? What about site supervision? I suppose, you know, going back a few years now, clerk of works and the sort of things, you think site supervision was better in the 90s. I mean, and it seems almost absent now. So got any thoughts on that, whether we should be getting to, you know, better supervision of what goes on site?
Well, I think that we've got to think about that sadness, which is people cut back to reduce the costs. And with that, you went through the removal of many of the people who I remember being the people who I worked with. When I worked in Belgium, it was clerk of works, or the equivalent of, who were the ones that I was relating to. They were the ones who were doing the job. I went to them. I didn't go to the contractor, because what you'd be then fed was all the details of what they were doing, the prices, the costs, the alterations, and so on, not the quality. And because we were putting up a building, which was the Common Market headquarters, it was one of those things where you needed to have the first-hand touch with what was going on. These buildings, the one I was involved with that collapsed in Ashford, are fairly low quality buildings. They're not the big ones that perhaps that would have been justified on. In Sampoon, there you've got an overriding influence of the people who own the building, who were not going to listen to negative comments and didn't want the building work slowed up or halted by some petty official. They just paid them off. So to some extent, you've got this balance. A good clerk of works will make sure that the work is done and done properly, but it will slow the product, it will slow the delivery, and that costs money. And it's that double-edged money element which has driven them out of the circuit and out of the control of quality.
Can I just ask either Phil or Malcolm just to explain what a clerk of works is?
John, Phil?
I know you'd say that. Thank you, Malcolm.
Thinking there's so, you know, there's some in the group, you know, also who are listening who might not understand what that is.
Well, normally it's an on-site supervisor, and depending on the size of the job, they are, well, and by looking at what Craig Smith was saying, that they're employing clerk of works, or cows as they used to be known, or still are, and they're paid for normally by the clients, often as part of the architect's fees, and they're expensive. They're basically on site for an awful lot of the time. They're usually ex-tradespeople, and they will be going along to see what mix of mortar the contractors are using, whether the damp-proof courses are in place. But they're more than, say, the building control inspectors. They're about quality of construction and materials, as well as safety issues. So yeah, Craig was saying, my golly, 36 grand for each. Hey, Craig, can I be a clerk of works on your sites? That's pretty good. But yeah, you got to pay for quality and safety.
Yeah. So a couple of things just to finish up on, and thank you very much, Malcolm and Phil, for your time today. The first thing I would say is you can start making a difference on this by spreading the word, not just spreading the word about, you know, this webinar, but talking about what you've learned from it, and, you know, that we need to call it out. You know, you're all on social media, you know, you can connect with us, tag us, whatever, but spread the word, because if we don't do that, you know, everything that we've just learned just becomes contained to the people that have joined this webinar, and it's too big an issue. You know, the more pressure that we put on, the more that we can change things. Secondly, do check out, I've put a link into the chat, but do check out the proposed rules of conduct by the RICS. So they're proposing a new change that includes things like treat each other with respect, you know, which talks about discrimination, but also then leads into things like, well, whistleblowing, how do you do that? So that will give you some good insight. But other than that, just thank you very much for your time. This will be on replay if you had to jump out or lost any signal during the time. But yeah, thank you very much again, everyone. Take care. Have a great day. Bye.